Hello folks, in this tutorial I would like to show you how to use the concept of a law in Catia v5, specifically in a sketcher. Uh, and I'll do a simple example, although I point out that this is not the most efficient way of doing the problem. However, it sheds some light on sketcher slash law. Okay. Now, the law can be found, the icon for law, which is F composed with G, or some people call it FOG, can be found in the knowledge toolbars, as you'll see right next to the design table. And if you check the documentation, it tells you that basically this is what it does. So it's a single input, single output entity. Okay. And when you create it, it appears in your tree uh, as shown here. Now, I will do this example for you at the very end. However, for now, I'll just concentrate on one specific point, and I'll show you the slides, but I'll come to them as I use them. So let me remind you, here's the icon for law, knowledge toolbar, right next to the design table. You can find it. And when you click on this icon, a dialog box law editor shows up, and it gives you information about the author, the date, etc., etc. And when you say OK, then you get this dialog box here that you have to fill it in. Now, uh, and I'll do my example. The Just be patient with this slide. We're going to come to it. You can type your stuff here. First, you have to define parameters. These are called formal parameters. And these formal parameters, you can define them only here. They're not going to get transferred to the tree, or it's not visible to the rest of the database. And then you write your code. And the example that I'm going to do is the following problem. I create a point which has these two dimensions, and the law will say that if the horizontal distance, if the horizontal distance or the horizontal dimension is less than or equal to 1, then take this thing uh, and square it, and that's going to be your new dimension. So, and the way to do that, you select the vertical dimension that you want to change according to that law. This is your y basically, and go to right click, go to the editor, edit formula, and when you do that, this dialog box opens up, and then you have to do the rest of the problem. I'll do that for you in a minute. Okay. These slides, will come back to them. For now, I'll quickly show you what they are. We'll come back to that in a minute. Okay. We'll come back. And notice that it changed. It will change because this dimension that I put in there was actually 2.117 inches, and it's not less than 1, so it keeps the height as 1. It doesn't put it in that formula for squaring things, okay? All right. Yeah, we'll come back. All right, let's go here. And first, let me create my law. And my units are already in inches. So you go to the knowledge toolbar, right next to the design table. You see F composed with G. Here is the name of the law and the author. And I'm going to go there, and I create my parameter. New parameter, I'll call the first one X. And another one, I'll call this thing Y. Okay. So these are the formal parameters that are defined in the law. And what I'm showing you now is this thing. I created my formal parameter. Now I'm going to put in my code basically. So you go here. All right. So if x is less than or equal to 1 inch, then for y, you take that thing and square it. Y equal to x star star 2, squaring it. However, the unit now is going to be inches squared, so you have to divide that by 1 inch. So the unit becomes y equal to essentially square of x, whatever it happens to be, and then divided by 1 inch. Else, y equal to 1 inch. So this is my law. All right. And then we say, okay, if there are no syntax error, it creates the law for you. It's right there. You can double click on it. Notice that if there are any syntax errors here for x, I'll put a parenthesis here, and there will be a syntax error. Notice that it catches. But I didn't have any syntax error, so I just backspace, and this is fine. No problem. All right. Now, I go to that vertical plane. Right now, I'm not in part design, so let's go to the part design. I select that vertical plane. I sketch. I select a point, and let me do the point here. For example, here's how you create a point. Right there. See that? Right there. Okay. And let me put those dimensions for you. Horizontal, it was 2.177. 2.1117, I think 2.117. And for vertical one in that slide, I had 0.958. These are just random numbers. I want to stick to them because my slides look like that. And hit enter. And there we are. Okay. So let me move this thing down. And notice what I'm showing you now is this slide. I created this point. Now, I put the cursor on the vertical. I put the cursor on the vertical dimension. Right click. Go to edit formula. Edit formula. Okay? Edit formula. So what you see now is this slide. Okay? Edit formula, this slide. Now, from the tree, select this law. Notice that it goes and catch this law. And if you left double click on this, it puts it over there. Okay? So now what I'm showing you is right there. See, put it over there. And then you go and select the law from the left pane. This guy pops up. See that? This guy pops up. And left double click on this. It puts it over there. So what I have now is this slide. Now make sure you put the cursor between these two parentheses and select the horizontal dimension. Okay? All right? Let's do that. See? You put the cursor between those two parentheses and select the horizontal dimension. So let me go do that for you. Put the cursor right there. Select the horizontal dimension right here. And so what I have for you is this slide. Okay? And then when you say okay, it gives you that update information and say yes. Notice that right now the dimension is 0.958. As soon as I say yes, it changes it to 1. So basically it goes through that law. It says, what is this dimension that I put in there? If it's less than or equal to 1, it's going to square it. But if it's not, then it'll take the value of 1. So basically I've done this problem for you. And now I want to go back and do that one. Okay? So keep in mind that I had to, uh, when I squared x in my law, I had to divide by 1 inch. Otherwise, units will not match. If this is length, if this is inches, this must be inches. Okay? But if I just left it as x squared, it'll be inch squared. All right. So let's go ahead and do our problem. All right. So I'm going to delete this. I'm going to delete the sketch. Let me go to exit this first of all. Delete the sketch. But I'm going to keep my law there. We need it. So on that vertical plane, I will sketch. I'll create 3 points. The points that I want actually have these x coordinates, but the y's are arbitrary. For example, I can go and say a point 0 for horizontal. You just leave it the way it is. It doesn't matter. I'll just change this thing to be a little bit different here. So there's 1 point. Another point. Now this is going to be 0.25. 0.25, right there. Okay, let me zoom in a little bit. What I'm trying to do is to create these 6 points. Already did two of them. Another one, another one, another point. The x of a horizontal is 0.5, and for vertical, whatever it is, it really doesn't matter. Right there. Okay, another one, and that other one is going to be 1. You can see that. The other one is going to be, I'll put a 1 here, and yep, right there, and 1.25 and 1.5. So another point right there, 1.25, is your 1.25 and whatever it is, and the last one is 1.5, 1.5, and whatever it is, it doesn't matter, right there. Okay, so what I've done, I've created 6 points. 1, 2, 3, 4, 5, 6. Their x coordinates are correct. So let me actually move these things a little bit further down so that I can see them. Here's one of them was 0. Actually, it's right there. This is the one that was 0, 0. Okay. Then I'm going to move this thing down so I can see it better. Then I'm going to move this thing down, 5. And then there was 1, the value 1. I think it is, which one is it? It must be this one. Yep. And then 1.25. And then 1.5. So what I've created is actually these points, except that the heights are not correct. The x's are correct, but not the heights. So I know that there's a law for this. If x is less than 1, I have to square it, and that's going to give you the height. And if otherwise, it's going to take the value of 1. So let's go ahead here. So I created these points. And I rearranged it so you can see it. But now I need the vertical dimension. So let me go and the vertical dimension here from here. Where's the first point? This is the first point. From here to this is the first vertical dimension. Now we go from here to here. This is the second one. Now there to there is the third one. From there to there is the fourth one. This one there is the fourth one. And this one there is the fifth one. Okay. So basically, we have a situation where vertical and horizontal dimensions are defined. The horizontal ones are correct, but not the vertical one. Okay. So now we go and select. Let's start with the very first one, where the very first one was actually this fellow, right there. See that point? Select that dimension. Right click. Edit formula. All right. Select the law. Put this thing up there. Click on this law. Evaluate, put the cursor between the parentheses and select that horizontal that horizontal dimension, which is right there. And then we say OK. And here's the automatic option, automatic update. Say OK. What happens is that that point, which was way up there, jumped to the location 0, 0. Do it again. Select the second point. There is the second point. Right now it's up there. You can see that it's up there. It's going to jump to the coordinate 0.0625. We'll see. Okay, so right click, edit formula, select the law, put this thing up there, click on this law, select evaluate, and select that dimension, that horizontal dimension, which was that 0.25 right there, right there. and then we say okay, and this will jump to 0.0625. Right there, 0.0625 is rounded for visual purposes. Okay, let's try it again. Let's go to the next one. There we are. Select this, right click, edit formula, select the law, uh, put this thing up there, click on this law, evaluate, select the cursor, and put that dimension 0.5 right there. It was 0.5, right? And let me say okay, and jump to that location. So this is height 0, this is height 0.0625, this is the height 1, okay? And let's go to the other 3. So select the next one is right there, right click, edit formula, click on the law, put this thing up there, click on this law, put evaluate up there, and select that dimension which said 1. It's that point, right? It's the third point, this dimension. This is the 1 dimension. And then say okay. And it brings it down here, okay? And actually, I just noted that the concavity of this is not correct. This is not drawn to scale. So actually, it should go like this. And it is going like that. Okay, next one. The next one is going to be right here. Edit formula. Select the law. Put this thing up there. Click on this law. Put the evaluate up there and select the proper horizontal distance, which is right 1.25 right there. And then say okay. And notice that it jumps down to 1. And last one, this is the last dimension. Right click, edit formula. Okay, select the law from the tree. Put this thing up there. Double click on this law. Evaluate and take the last dimension, which was, I believe it must have been this one. Yeah, this one. Say okay. Update. And we're good. So look at what happened here. If I zoom in, let me move these things up so that you can see better. Five 0.025, 0.15, right there. Let me move these things a bit closer here so that I can see things better. Okay. So this is what happened. I have my points. There's a point here, coordinate 0, 0. There's a point here, coordinate 0.25, 0.0625. There's a point up here, which is coordinate 0.5 and 0.25. And point over there, coordinate 1, height of 1. Coordinate 1.25, height of 1. And coordinate 1.5, height of 1. That matches this. And I'm really sorry about the concavity. This should have gone like that. Should have gone like this. Okay. However, it did work. I showed you an application. And once again, I'm saying that this is not an efficient way of doing things, but at least it shows you how the law can be used if needed. And, these are the comments that I made. You might say that, uh, if could I not have used a formula, a regular formula, not the law, to do this problem? Well, the problem is that you have an if statement there, conditional statement. You cannot put a formula in a formula, a conditional if statement. Okay. Also, uh, if I had, for example, 50 of these every time if even if it was not even if it was not the conditional if statement, it was, for example, y equal to sine of something of involving x. Every time you have to copy that if you use the regular formula. Here I created the law once and for all, put it up there, and then use it with the appropriate input and the appropriate output. All right, folks, good luck.